First of all, welcome to all in online lecture series. So I am Professor Sandeep Aher as a lecturer Sandeep Polytechnic, Sandeep Foundation, Nasik. So friends, today we are going to discuss that is non-traditional machining processes. As previous lecture, we have covered three non-traditional machining processes with need of non-traditional machining processes, its importance, its a distinguish, then wire cut electro discharge machining processes, then electro discharge machining processes, and then abrasive jet machining process. So similarly, this is the fourth type of non-traditional machining processes as electrochemical machining processes. This is a separate category of the non-traditional machining processes. So let us see the principle. This is the electrochemical non-traditional machining process which works on the basis of reverse electroplating is used to cut the material by using electrolyte. So this is the basic principle. So every time in the principle you have to mention which energy level under this process. So this is the electrochemical non-traditional machining processes. That is a non-conventional machining processes which works on the base of reverse electroplating. You just observe this figure. For purpose I have provided one figure. So every process there is a one cutting tool and one workpiece. So cutting tool always negative electrode and workpiece always positive electrode. That electrode means that material should be conductive. Now, what is meant by electrolyte? So, electrolyte is the fluid or gas which allow to pass the current. So, that fluid known as electrolyte. It may be sodium chloride, sodium nitrate, sodium potassium, potassium nitrate, potassium chloride, like this. Now, in this figure, you just observe this figure. So, workpiece and tool. Here, observe this. In workpiece, same type of cutting tool, whatever extension portion, that same cavity should be formed here. So that is the main function of that electrochemical process. So now this is the initial stage and this is the steady state, means after process. Now what happened here? This is a cutting tool. Cutting tool always positive plus electric ion. Here also positive plus electric. But in workpiece to remove the material, that's why it's always towards the negative ions. And in cutting tool always positive ions. So that process get deposition of material in form of vaporization or melting like the chemical way. So we'll see the next setup of the electrochemical machining process. Now you observe here that figure setup is as look like same as EDM process, electro discharge machining process. But their principle is different and here principle is different. Because in every theoretical question you have to write in the same manner principle, construction, working, its setup, then process parameter, then advantage, then disadvantage, and at the last application. So yeah, here one of the container and container fills one of the electrolyte fluid. Now in electro discharge machining there is a dielectric fluid. So what is the basic difference between electrolyte and dielectric fluid? Dielectric is the fluid when voltage is high, then it allow to pass the current, otherwise it is used as a insulator. But in electrolyte it always allow to pass the current. So that is the difference. Now here similarly one of the cutting tool and one of the workpiece. Now in this process cutting tool and workpiece are both are the electrodes. That means both are the conductive material. That should be very important. Then this workpiece is mounted on the some picture or like this. So these electrolytes fills in the container, and then position of the workpiece always connected to the positive electrode, and sorry, workpiece always negative electrode, and cutting tool always electric negative electrode. Now what happened? It required DC power supply for high voltage and current. So let us see this process how it works. So when DC supply is switched on, then this supply is on to this electrode. That electrode material should be tungsten, graphite, brass, copper, like. Okay. So these materials, that positive ions and negative ions, so that negative ion moves towards the workpiece, and whatever workpiece, that positive ions moves towards the cutting tool. So that negative ions moves here, so chemical reaction is takes place, and that chemical reaction to remove the material in form of the cutting tool. So here also to maintain the gap between cutting tool and workpiece as near about zero point 0.5 mm. So this is the electroplating. But that material removal in form of chemical, so that material gets deposit, the electrolyte never deposit on the cutting tool. So that is also main important point. So that electrolytes is continuously filtering, that is very important because raw material gets mixed with the electrolytes. So that purpose the system is provided that pump and filter. So pump that electrolytes is supplied low pressure to high pressure with passing through the filter to remove the impurities, and continuously supply to these electrolytes of the cutting tool. Okay. So let us see one by one. Its construction. First, it consists of the following components: electrolyte, electrolyte supply and cleaning system. In ECM process acts as a current carrier because that electrolyte says the it's only allowed to current. Supply system consists of piping system, storage tank, pump, control valve, pressure gauge, heating, cooling coil, etc. Then ECM, the metal removed from the workpiece from the sludge which should be removed from the electrolyte. This system control the flow and cleaning of electrolyte solution into the container. So that is the system. Then tool material. I already said that tool material always negative terminal. Tool materials of ECM must be thermally and electrically conductive and highly resistant to the corrosion. The electrode is generally made smaller than the cavity desired because the erosion action progressing outward from the electrode always produces a cavity larger than the electrode. So that point is also important. So whatever cavity is formed, that cavity should be larger than the cutting tool cavity. So third, power supply. This is a common parameter for the every processes. So DC power supply is used for the ECM. Then fourth, workpiece and work holding system. So in electrochemical machining processes, so workpiece should be well electric conductive. The work holding devices should have non-conductive property. Means that fixture is always non-conductive material. Now working. It is the negative type of manufacturing processes because it removes the material. Then electrochemical machining works on the base of Faraday's laws of electrolysis, because here chemical action is takes place to remove the material, so under these Faraday's laws of electrolysis. These laws state that if two electrodes are placed in container which fill with the conductive liquid or electrolyte, and high ampere DC voltage is applied across them, metal can depleted from the anode positive terminal and plated on the cathode negative terminal. This is the basic principle of electrochemical machining. So here cutting tool always positive and workpiece always negative. So in this process, tool is work as a cathode connected to the negative terminal, and workpiece as a work as an anode connected to the positive terminal of the battery. With a small distance between them, they both are placed in an electrolyte solution. Because electrolyte solution means that liquid or gas should always pass through the current. And when the DC current supplied to the electrode, metal removed from the workpiece. And electrolytes acts as current carrier. High rate of electrolyte movement in the tool workpiece gap washes metal ions away from the workpiece anode before they have a chance to plate onto the tool cathode. Next, we'll see as per the process parameters. So every time that power supply is required, so that DC current is 50 to 40,000 ampere, voltage 2 to 35 volt, current density 0.1 ampere per mm square to 5 ampere per mm square. So there is no need to remember that exact parameter, but near about that range should be required. So electrolyte, that materials already said that sodium chloride, sodium nitrate, then its temperature range is 20 degree to 50 degrees Celsius. Flow rate 20 liter per minute per 100 ampere current, and its pressure range is 0.5 to 20 bar. The working gap, the always gap between cutting tool and workpiece 0.1 mm to 2 mm. Then feed rate is required for feeding the tool as per the depth of cut. So that feed control by the servo mechanism. So that is always required. So that is 0.5 mm per minute to 15 mm per minute. It depends on its current intensity. Okay. Then electrode material, that should be copper, brass, bronze, tungsten, line. Sometimes question may be there to write the any two or four electrolyte material. So you should know the sodium chloride, sodium nitrate, sodium potassium, potassium nitrate, like this. Remember at least four process parameters. I think these process parameter, 2 to 3 parameters are always repeated in every process. That power supply is common, then working gap is common, then feed is also common. So next, let us see advantages of electrochemical machine. Here, negligible tool wear, there is no tool wear near about, so negligible tool wear, and no burr forms, because non-traditional machining process it is a burr free operations, and high surface quality. There is a common advantages of these every processes. High accuracy, like the rate of machining does not depend on the hardness of the workpiece material, because there is no contact between cutting tool and workpiece, so that the rate of machining does not depend on its hardness. No chemical forces applied so no stresses are produced on the workpiece surfaces, because there is no generate the like thermal base heat, so that's why no stresses are produced on the workpiece. So similarly, as limitations, so some common limitations for these non-traditional machining processes, that is higher initial cost, not eco-friendly processes, because there is a chemical action is there, so it should be hazardous to the pollution, that was not eco-friendly process. Only electrically conductive materials may be machined, then corrosion of the equipments may cause due to electrolytes. So you have to change that, or every time you have to observe the properties of electrolytes, its viscosity, its thermal conductivity rate, like this, because that material should be corrosion resistance. Large production floor area is required. Then at the last, application to machining disc or turbine rotor blade. To machining disc or turbine rotor blades, then die sinking, and die sinking, then multiple hole drilling. It is a common application for the every processes, and micro machining. When your mole material removal rate is very minor, so you have decide that electrochemical machining process. Let us see, we will continue that next process, that is electron beam machining processes. But here that process is under the thermal base energy level. So let us see principle. This is the electrothermal based non-traditional machining processes which works on the basis of kinetic energy of electron into the heat energy is used to cut the material. So electron beam machining. Electron and one of the beam. So there is a one of the gun is there to emit these electrons in the high velocity. So that is a high kinetic energy. And machining, that is a process to removing the material. So that high velocity of kinetic energy of electron is converted into heat energy by means of magnetic lens, deflecting coils, like this, and used to cut the material. So that word is very important, that electrons of kinetic energy is converted into heat energy. So just will show the setup. So that setup of electron beam machine. So first you have to clear that this is a thermal based energy system. Now this figure you observe here, now the blocks are there, but you go through the one by one parts, that work table. So means fixture is provided. So that fixture rollers are provided. So why that rollers are provided? Because in electron beam machining, that high jet of velocity of electrons continuously striking on the single spot. That spot does not vary. So that purpose, removing the material purpose, workpiece is the provision to move in the certain coordinates. So that's why these coordinates also controlled by the MCU, machine control unit, is provided. Now here vacuum chamber. In this process is working under the vacuum, because electrons are in the high jet of velocity is passing through the from the gun to the workpiece. So avoid the scattering of electrons. That purpose vacuum is provided. Now for viewing port, means it is a transparent port is there. So how to cut that material, so that operator should be observe it. Then high voltage cable. So there is no there is a need to the high DC supply, that is to emit or generate the high electrons. So that purpose the gun is provided. So that is a cathode grid, that is a negative terminals, and anode always positive terminals. Okay. So that electrons are emitted, then wall is provided to regulate that. So that purpose. Then optical viewing system. We have observed that electrons how to flow gun to the workpiece. Then electron stream. There is the line I am showing here. So that line indicate the flow of electrons from gun to the workpiece. Then these magnetic lens are there. So magnetic lens are the contaminate on the single point. So that purpose is electrons amplified this. And deflection of coil, to avoid the scattering, it always moving the as per the work table, because in workpiece not a fixed position. So workpiece always movable, but then electron gun, that electron striking point is the standard point or fixed point for this position. So high vacuum pump is provided. So that vacuum is necessary, depends directly its surface finish. So that purpose high vacuum pump is required. So that is the simple working is there. So simple, you have to remember that process under the vacuum. Now electron guns to emit the electrons, this high velocity means, that means kinetic energy of electron is converted into heat energy through the magnetic lens, the single point, and thus to remove the material in form of the melting or vaporization. Construction same as we already discussed in the setup. So similarly electron guns, it is known as a heart of electron beam machine. It is the electron generator. It is used to generate the electrons. It is simply cathode ray tube which generate electron and accelerate them to sufficient velocity and focus them at a small spot size. And that material should be tungsten or tantalum. The annular bias grid, it is the next element of electron beam, that is a deflecting coil. Just after the electron gun, it is anode which is connected to the negative bias. So electron generated by the cathode does not diverge from the path and approach to the next element. That purpose that annular bias grid is provided. So magnetic lens further converges the beam into narrow spot on the workpiece. That should be concentrated on the single point. So electromagnetic lens and deflection coil to focus the electron beam at spot electromagnetic lens are used. And last, this is common vacuum chamber. Vacuum helps the electron do not lose energy by collision with air molecules or scattering. Similarly, working process, it is the negative type of manufacturing processes which works on the thermal base. High kinetic energy is converted into heat energy, then and then possible to remove the material from the workpiece. Then EBM works on the basis of kinetic energy of the electron into heat energy, and electron beam gun is used to generate electrons, and high velocity of electrons over very small spot size are provided by electron beam gun. Electron beam gun is required to carry it out in vacuum, otherwise the electrons would interact with the air molecules, thus avoid this scattering. To avoid this workpiece to be machined is located under the electron beam and is kept under vacuum. That point is very important. that process under only vacuum. When high speed electrons strike on the workpiece, they convert its kinetic energy into heat energy, and that heat energy to vaporize the material or melting the material at contact surface. And thus finally the molten material, if any at the top of the front, is expelled from the cutting zone by high vapor pressure at the lower part. Now as per the some process parameters of electron beam machining. So the accelerating voltage is a power supply, that is a 50 to 200 kV. Then speed of electrons. When we are going through this process, so that process parameters already known, but most of students not mention. So every time you have to mention that process parameter, that speed of electrons, that range may be near about standard parameter. And spot size 10 to 100 micrometer, because there should be gap. The beam current, then pulse duration in the per second, the energy per pulse, whatever energies are required for the to generate the pulse, then power per pulse, total power is required for this pulse. So these are the process parameters. Then advantages of electron beam machine. Common advantage: high accuracy, excellent method for the micro finishing. Then it is possible to cut any known material. That process is almost used for the cutting or welding purpose mostly. So no cutting tool pressure or wear occur in this process because it is totally depends on the electron velocity. So there is no tool wear. As it applies no chemical cutting force, work welding and fixturing cost is very less. And workpiece that cut material of the workpiece is mounted on that fixture, and that fixture is always movable because in concentrated or high jet of velocity of electrons or only single point, so does not move that tool position, so always move the workpiece position. So very small size holes can be produced, and surface finish produced is very good, and it is also burr free operations. Okay. Then limitations. So this is a common limitations are there: high equipments or initial setup cost, high maintenance cost is also common disadvantage for the all non-traditional machining processes, that maintenance cost is also high. Then high skill operator is required because that system is very sensitive, that purpose high skill operators are required, and this very common disadvantage for this process, and this is very important. So it required vacuum to avoid the scattering of electrons. And the last we'll see the applications of electron beam machining. It is used for producing very small size of holes, like holes in diesel injection nozzles or air brakes, etc. Therefore, precise holes are required, then and then electron beam machining process is used. Used in aerospace industry, in nuclear reactors, means high edge technology parts are used that type of machining process. Sometimes engraving of metal or ceramics. So engraving means that is a removing material in form of minor, like you observe steel rule, so that every lines are engraved. So that type of process should be done by this electron beam machine. Then it is mostly used for the welding purpose. Already said that that process is always used for the welding purpose, or sometimes cutting purpose is also there. So I hope to understand the first process as electrochemical machining and this electron beam machining, because electrochemical machining It is the electrochemical base, and this electron beam machining, this is the thermal base. So thank you.